Satellite servicing allows satellites to work longer in space. Every year, functional satellites providing weather data, communications, and other essential services are retired because they reach the end of their fuel supply. So, as old or ailing satellites are moved to the graveyard orbit, replacement models are financed, designed, built, and launched, a process that can be costly and time-consuming for satellite owners and the consumers. Now, to prevent this wastage, NASA is building a system that will keep satellites working longer in space. But how will they do that? Let's find out. Welcome to Space World. In today's video, we are going to talk about a satellite repair and refuel system being built by NASA. So if you want to know more about it, then stay with us until the end of the video. Refueling a satellite in space, from what we know about filling up our cars here on the ground, it sounds pretty simple, right? Just open up the cap, connect the fuel nozzle to fuel the tank, and send the satellite on its way. Like many things in space, it's much more complicated than you would think. First, the fuel valves on the satellites in space today were never designed to be accessed after launch. To prevent hazardous fuel from escaping during launch and operations, satellite manufacturers tightly lock down the fuel valve with wired shut caps. These caps must be removed before anyone can access the valve. Then, pumping fluid in the microgravity environment of space is a completely different matter than transferring fluid on the ground. Without gravity to settle the fluid in the bottom of the tank, like on Earth, tank plumbing and pumps must be more specialized to correctly operate in the microgravity environment of space. Finally, to make the challenge even more complex, the majority of the satellites that would benefit most from servicing are in geosynchronous Earth orbit, or GEO. GEO is inaccessible to humans at this time, which means that only robots can do the job. So, considering all this, NASA is planning a mission to demonstrate the feasibility of repairing and upgrading satellites in Earth orbit. The mission, called OSAM-1, will send an automated spacecraft equipped with robotic arms and all the tools and equipment needed to repair, refuel, or extend the life of satellites, even if they are not designed satellites for service in orbit. The first test flight of OSAM-1 is scheduled to launch no earlier than 2026, and it will enter low Earth orbit for rendezvous, acquisition, and docking with the Landsat-7 Earth observation satellite, which has been in orbit since 1999. A first-of-its-kind demonstration test to refuel and then move a satellite into a new orbit. Although some parts of the mission are autonomous, human teleoperators will perform most of the procedures and maneuvers remotely from Earth. NASA says refurbishing satellites rather than just letting disabled spacecraft drift around Earth's orbit is helping to reduce space debris to create a more sustainable future for space exploration. Amazing, right? But where did this amazing idea come from? The original idea for a satellite to serve a spacecraft came from renowned NASA engineer Frank Sciapolina, who repairs spacecraft in orbit. He led the teams responsible for planning and staging 5 maintenance missions for the Hubble Space Telescope. He helped develop the specialized tools and procedures that astronauts will use to successfully repair and upgrade Hubble, keeping the venerable telescope operating for years longer than anticipated, and allowing better instruments and technology to be installed on each successive mission. He also led teams that developed methods for repairing other satellites in the early days of the Space Shuttle era. It's amazing to me that we're just throwing satellites into orbit, Sciapolina stated in 2016 when he visited the Robotic Operations Center. It seemed that we had to find a way to fix these satellites for economic reasons and for the scientific benefits we could reap. I wanted to find a way to fix and upgrade the satellites. Sciapolina, now 85, has just retired from NASA, but he has nurtured and trained generations of engineers, never giving up on his dream of repairing satellites. After several mission service proposals, the concept was formally recognized as a mission and given line item status in NASA's budget. But there is still a lot of work to be done to be ready for a launch by 2026. When you do something for the first time, there are a lot of new technologies and procedures, and you inevitably run into obstacles and setbacks, And we are no different, said Ross Henry, OSAM-1 Payload Maintenance Manager, in an interview with the Universe Today. We are dealing with several new systems, such as a new LiDAR system, light detection and ranging, a unique fuel delivery system, and 2 robotic arms. One is a redundant backup, which can use 11 unique tools and adapters, each designed for a specific purpose within the mission. So, the main purpose of the first test flight of OSAM-1 will be to refuel Landsat-7, which is located at an altitude of about 705 kilometers, 440 miles above the Earth. But because Landsat-7, like many other satellites, was never intended to be serviced and never even seen again, the OSAM-1 spacecraft can't just drive up next to another satellite and plug in a fuel hose. First, OSAM-1 will need to get close enough for one of the robot arms to lock onto Landsat-7 and then perform docking maneuvers using the original docking clip, or the Marmon ring, on the satellite. Then we have a lot of work to do to gain access to the gas station, Henry explained. OSAM-1 remote operators will have to cut the multi-layer insulating thermal shell and move it out of the way to expose the fill and drain valves. But when they were closed before launch, those valves were covered with a blocking wire, so we'll have to go with special scissors and cut them. In addition, we will remove the extra protective caps. In addition, OSAM-1 will carry 122 kilograms of fuel, and it is planned to transfer 115 kilograms of it to Landsat-7 using a robotic arm and retractable hose system. Of course, all of this happens when both spacecraft are traveling at about 26,500 kilometers per hour. Furthermore, OSAM-1 carries 6 rendezvous and rendezvous cameras for use when approaching Landsat-7. An additional 21 cameras are part of a specialized vision sensor system, allowing cameramen to view operations from all angles, while searchlights provide illumination for operations. This mission was previously known as Restore-L and focused solely on refueling and repairs. But in February 2019, a new component called the Agile Space Infrastructure Robot, SPIDER, was added to the mission. SPIDER includes its own 5 meters robotic arm, bringing the total number of robotic arms flying OSAM-1 to 3. SPIDER will assemble a live 3-meter communications antenna built from parts delivered into space and demonstrate K-band transmissions with a ground station. SPIDER will also fabricate a 32-foot lightweight composite beam to test the feasibility of building a large spacecraft in orbit. Although all of this sounds mind-blowing, but the developments of all systems, tools, and methods required the participation of several areas of technology. And this is it for today, guys. What are your thoughts on today's video? Share your views with us in the comments below. And don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.